Hello, this is Geology Basics Mini Lecture number 12, Transform Plate Boundaries. We are comparing and contrasting transform plate boundaries and their characteristics to convergent and divergent plate boundaries here. Our big question is, what's happening at transform plate boundaries and what types of activity, tectonic activity that is, and features occur there? The major learning goal that we are hoping you're going to be able to do after working through this and other course materials is to describe the processes that occur at transform plate boundaries. So let's review what's happening at transform plate boundaries. We've got our usual two ways of looking at plate boundaries here. We've got a cross section, that is, we're looking through the layers of the Earth from the side. We've got the lithosphere and the plates that go along with that, the asthenosphere on the bottom. And we've also got the map view. And so if you recall, we can't really see much happening from the side or a cross section. We've got one plate moving into the page of the textbook, if we're imagining this image to be that, and one plate moving out towards us. So it's a little bit easier to see this motion from a map view, where we have one side, that would be plate 2 sliding sort of backwards or towards the top of the page, and plate 1 sliding downwards towards the bottom of the page here in our map view. Transform boundaries occur both on land and in the ocean or between the two. Unlike divergent and convergent boundaries, these really can occur anywhere between any types of crust that characterize the type of plate that's there, the type of lithosphere. There's no mechanism for melting at transform boundaries, so there's no magma produced or volcanoes. And hopefully you're noticing that in the cross-section, there's no blips of red or orange the way there are in the other two plate boundary diagrams, at least for some types of those plate boundaries. Transform plate boundaries on land don't produce large mountain ranges. We already recognize that they don't make volcanoes, which are a major way that mountains get made. But we can get small mountain belts or shallow valleys. In some cases, there's little lakes that form along the line of a plate boundary, a transform plate boundary. And this is the case in the US, where we have some transform plate boundaries in California. Medium to large size or magnitude earthquakes, and those that are only at shallow depth, occur along faults that are related to transform boundaries. So nothing really big and nothing really deep tend to happen as far as earthquakes at transform boundaries, but earthquakes are very common. Transform plate boundaries that occur between two plates that have oceanic crust on top, or plate boundaries that are in the ocean, are very similar to those on land, but typically along the ocean, they're going to form nearby mid-ocean ridges, and this often makes a zigzag pattern where you have a divergent boundary segment right next to a transform boundary segment, right next to a divergent boundary segment, as is shown here. So no melting is actually occurring at the transform boundaries, so no magma is occurring and no volcanoes are produced. And this may be misleading in this diagram because we're also showing the divergent plate boundary, which does produce magma and have volcanoes associated with it. So let's review the types of tectonic processes that are at transform plate boundaries. And really there's two that are occurring here. Faulting, the formation of faults, is the last on our list. That is occurring here. And earthquakes, mostly shallow and relatively small to large magnitude, that is, something that's less than 8 in the magnitude scale. What about mountain building? This is listed with a question mark here. As we noted earlier, we can get some small mountain ranges that are mountain belts that are associated with transform boundary, but nothing like the very large Andes Mountains or other mountain ranges that are produced by volcanism and also crustal crumpling at convergent plate boundaries. So what do those processes result in then? What characteristics or landforms are at transform plate boundaries? The faulting, the breaking of the rock, produces faults along the transform plate boundary location. And Maybe mountain ranges on land. That's about it. Nothing else of our characteristics or landforms that we tend to see with other plate boundaries occur here. In this map view, transform plate boundaries are highlighted by the bright green sort of highlight or color. And you might notice they mostly connect up other boundary segments. Mostly they're nearby divergent boundaries, but they can occur anywhere. So a lot of times we think of transform boundaries as kind of the link up areas where, because of the way the plates are moving in certain locations, plates are not directly converging and they're not directly pulling apart, but they're kind of having that side-to-side motion. And that's usually the case, although you might notice there's some swaths where there's very long areas of transform plate boundary segments, and so those are maybe the anomaly. A practice question for you here. Which of the available options for features, tectonic activity listed in A through E would you expect to see at only a transform plate boundary? As usual, please pause the video while you consider your answers, come up with the best option, and then unpause it and we'll reveal what the best answer is. The best combination of features that would match what we know about transform plate boundaries would be D, shallow earthquakes, faulting, and no volcanic activity. So how about A? What's wrong with A? Mid-ocean ridge, that's associated with divergent plate boundaries. Trench, associated with convergent plate boundaries. Volcanoes, volcanic activity are associated with either of these two boundaries, but not transform boundaries. Shallow earthquakes can occur at any kind of plate boundary, so that doesn't end up being helpful. How about B, collision? Well, collision only happens to two continental plates on that are converging, have convergent plate boundaries, so that's not going to work. Deep earthquakes don't occur at transform plate boundaries. We kind of get mountain ranges on land, but not normally what we would think of as the large mountain ranges on Earth. So B is not going to work. How about C? Mid-ocean ridge doesn't work. Rift, both of those are associated with different locations of divergent plate boundaries. And then volcanoes of volcanic activity, also not associated with transform plate boundaries. Deep earthquakes, also not going to work. So many things not going to work in C. How about E? We've got the same sort of situation as we've seen in other options here. The earthquakes for transform plate boundaries are limited to very shallow depths, and there's no volcanic activity, so those two won't work. The trench is another of those characteristic features that are only found at one kind of plate boundary, and hopefully at this point you're associating that with a convergent plate boundary that has subduction. So hopefully this is a good review. Any questions, please don't hesitate to ask.